Hey, fellow problem solvers, Colfax Math here. Today we're going to look at surface area and volume of a pyramid, a cone, and a sphere. This is all for an IB Math class. It is IB Math SL AA, Chapter 11 in this Oxford Mathematics book. Okay, so first thing is a series of equations, and I have them written on the board here. The surface area for a pyramid, this is a square-based pyramid, so the bottom's a square, and it's regular, meaning that everything, the vertex, is perpendicular to the base through the altitude. It's the base squared, each side of the base squared, plus 2 times one side times L. That cursive L is slant height, and we're going to talk about that. The volume of that pyramid is 1/3 base area times the height. So we have 4 variables here. We have the sides of the square, the slant height, and the height. And then also we're going to have the edge as well. In a cone, this cone right here, say we're upside down, either way, still a cone. Again, this is a circular-based cone that's right. Area of a circle is pi r squared. So the surface area of the whole thing is the area of the bottom, pi r squared, plus the lateral surface area, which is pi radius times slant height. And then the volume of a cone is 1/3 pi r squared times the height. So again, that slant height is the edge from here to here, lowercase l, versus the overall height is from right here at the top to right here at the bottom. And our third geometric solid is a sphere. The surface area of a sphere is 4 pi r squared. And the volume of a sphere is 4/3 pi r cubed. Because we are in 3 dimensions for volume, our units are going to be cubic. So this will always be cubic inches or whatever it is. Surface area is 2-dimensional, so your units here would be squared, like square inches, square centimeters. Probably the easiest one to do first is just a sphere. There's only one missing variable, that is radius. So if the radius is equal to 2, and I wanted to find the surface area, I take that 2, I plug it in here, exponents first. 2 squared, 2 times 2 is 4. 4 times 4 is 16. Don't forget that pi. And I have 16 pi for the surface area of that sphere if the radius is 2. If the radius is 2 centimeters, then my units here would be square centimeters. This is an exact value answer, meaning I didn't use a calculator at all. I could also take that 16, multiply it by 3.14 on my calculator and get the approximate answer, whatever that is, 50th or so. Okay, let's take a look at the volume of a sphere using that same example of 2 centimeters. I take that 2, I plug it in here for radius, 2 times 2 times 2. It's going to be 8. 8 times 4. 8 times 4 is 32/3 pi. Again, this is an exact value answer. I could enter that on my calculator to get the approximate. And that radius was in centimeters, so I have centimeters times centimeters times centimeters. So my units here would be cubic centimeters. All right, now let's take a look at a cone. So if I have a cone like this, let me try and draw this out here and put some numbers on it. I don't know, don't look too much like a cone. If that cone has a radius, so here's my center point, let's say the radius of that, we'll stick with that same 2 centimeters. So the radius of that is 2 centimeters. Let's say the overall height from up here to here, the overall height right there is 4. And then to find the slant height on the outside, let's make that green, I guess. The slant height on the outside, right here, I would go 2 squared plus 4 squared equals slant height squared. So that would be using the Pythagorean theorem. I'm kind of creating this right triangle here. So this slant height, again, L, would be the square root of 2 squared plus 4 squared. 16 plus 4 is the square root of 20. I could enter that on my calculator and get an approximate value, or I could just stay exact, but I do like to simplify this. This is made up of a 4 and a 5. A 4, I take square root of that to get 2 root 5. My check is square that and put it back in to get 20. So I have a slant height of 2 root 5. I have a radius of 2, overall height of 4. And I think I've come up with all of my variables there. And then you could see in a pyramid, it'll be very similar. Okay, so let's go ahead and find the surface area first of that cone. Let's stay with red here. So pi r squared. So I have 2. I plug it in there. 2 times itself, 4. So I'm going to have 4 pi plus pi times radius. Pi times radius of 2 times slant height. And slant height is 2 root 5. So I have 4 pi plus 4 root 5, 2 times 2, 4 root 5 pi. And I could just leave it like that as an exact value. Or if I want, again, I could enter in the calculator to get a decimal approximation. Now let's take a look at our volume. We'll do that in black here. Our volume is going to be, running out of room here, 1/3 pi. R again was 2 centimeters. So 2 squared, 4. Times our height. Our height now is 4 as well. So these are really all over ones. So I have 16 in the numerator, 16, 3 in the denominator, and a pi up here. This is going to be a volume measurement. So it's going to be centimeters times centimeters times centimeters, right? Centimeters times centimeters here, times that height in centimeters to give me cubic centimeters. And then this down here is going to be area, so it's square centimeters. Okay, again, the pyramid is very similar. The base area is not the area of a circle. You're just going to find the area of that square, which will be x times x. And then you're going to do 2 times that slant height. Might have to do a little Pythagorean theorem to find it if you're not given it. And then the volume is 1/3 this base area times the height. So that's how you find volume, surface area of 3 solids, the pyramid, the cone, and the sphere. If you have any questions at all, please post them in the comments. Hopefully that was helpful. Again, this will be part of a larger IB Math SL playlist on my channel. Thank you.